This video will walk you through doing an ANOVA using a randomized block design. And here I'm using the data set Serial 9. It contains data on 4 different cereal box designs, design 1, 2, 3, and 4. And 20 stores were used in the study. The goal is to determine whether the different box designs lead to different amount of sales, but this design process is used when you know that you might have a problem, like obviously larger stores will sell more cereal irrespective of what type of design they use. So they recognized this and they actually grouped the stores based on size. So there's 5 different size groupings, and then we can see the number of sales in each size grouping for each design. So this ANOVA using randomized block design, also known as two-factor ANOVA without replication, is done when you design a study to examine the impact of a treatment while recognizing that another input may influence your results. So you want to see, is there a difference in these 4 different designs for cereal boxes, but you recognize that these different sizes may have, the different store sizes may influence your results. So you're going to go into data analysis, and you will select two-factor ANOVA without replication. Input all of your data here, just the numbers. Oh, you know what? You may be able to select labels. Let's see. And select output range. Okay. All right. So this gives me two-factor ANOVA without replication. And I can see the average number of sales based on size. So it seems like size 5 clearly is the biggest, and that has the the highest average number of sales. And I can also see average number of sales based on design. It looks like design 4 is best. But in order to actually do that comparison and see, is there a difference in design once size of the store is taken into account, and is there a difference in size of the store once, or sales based on size of the store once design is taken into account, I need to go down here. So here where it says rows, that is going to be looking at our rows of data. So this is going to be testing HO, the 5, or the designs are, the average amount of sales is equal across all 5 size groups. And here that p-value is going to be less than 0.05. So I would reject HO and I would say yes, the sales, the amount of sales is different across the rows, meaning it is different across the 5 size groupings. But here when I look at columns, what I'm actually interested in, the columns, the design, my p-value is definitely not less than 0.05. So there is no difference here once, or in the 4 designs. So HO, all 4 designs are equal. The average number of sales for all 4 designs is equal, or the difference in sales for the 4 designs is 0. And I would not reject HO. I would say that there is not a difference in sales based on the design type once the size of the store is taken into account. So that doesn't look so good for our 4 design factors. We don't find one to be better than any of the others.